here we go for some more math action. This question is asking us to solve x squared minus 10x plus 18 equals 0. So, the way we'd have to do this so far is to first complete the square and then use difference of perfect squares. To factorize it, then use the null factor law. So let me do that really quite quickly for you. So it'll be x squared, then we'll change this to plus 2 minus 5x. Now minus 5 squared is, of course, plus 25. Now I've got to take away our plus 25 because we can't just add it in. Now plus 18 equals 0. So now this is our, let's complete our perfect square. X minus 5 squared. Now that's all of that. Now minus 25 plus 18 is minus 6, I believe. Minus 6, yep, equals 0. Now for our perfect difference of perfect squares bit, minus 5 squared, change 6 into square root of 6 squared. Now that all becomes, equals 0 of course, that all becomes x minus 5 plus root 6 and x minus 5 minus root, square root of 6 becoming messy, equals 0. Now using the null factor law, our solutions are either x equals plus 5 minus root 6 or x equals plus 5 plus root 6. Okay, so there we go. I did that fairly quickly, but there was quite a lot of work involved. Quite a lot of thinking and work and pain and annoyance. And you might be asking, isn't there a better, quicker, easier way to do this? And the answer is yes. The answer is the quadratic formula. The quadratic formula basically says whenever you've got a polynomial that's quadratic, that's ax squared plus bx plus c. Oh no, I've done something rather stupid. My apologies. That was much better. Ax squared plus bx plus c equals 0. Then the quadratic formula will let you find the solutions to it. Okay, to find the solution. So the quadratic formula says that x will equal minus b, that coefficient, plus or minus the square root of b squared minus 4ac divided by 2a. Okay, that's the quadratic formula. It's very important. You're going to use that so many times that it's just going to stick in your head without you even realizing that you're trying to remember it. Okay, so that's the quadratic formula. It will find the solutions to an equation like this really quickly and really easily. So let's do an example to show you how it works. Okay, so here's our example. We're asked to solve minus 3x squared minus 12x minus 7 equals 0. Now remember that solve is the same as finding the x-intercepts. And this fact that there's a minus here means that it's going to be a bit of an upside down sort of frowny face looking parabola like that. Okay, and we're finding the x-intercepts. So I think this one is going to turn out, if I was to plot it, look a bit like this. There's our y-axis, our x-intercept axis. Look a bit like that, so it'll be here and here is what we're trying to find. Okay, so let's just solve it using the quadratic formula. Okay, so our b is minus 12. So minus b is therefore plus 12. 12 plus or minus the square root of, I'll put my square root sign in a moment. I think this will be the neatest way. Okay, so b squared minus 12 squared is 144 minus 4 times a minus 4 times A is minus 3. 4 times minus 3 times C times minus 7. All of that divided by 2A. 2 times minus 3. There we go. Just one moment. Okay, so time to neaten this up a bit. So we've got 12 plus or minus square root of 144. Now 3 negative, so it's going to be negative. 4 times 3 is 12. 12 times 7, 84. Divided by negative 6. So that equals 12 plus or minus square root of 60 divided by minus 6. Let's see, square root of negative 60. Well, there are 12 plus or minus. 60 is 4 times 15. 4. 4 is a square number, so it can jump out in a moment. Minus 6. See what I mean? That'll be 12 plus or minus. Now the 4, square root of 4 is 2, leaving the 15 still as a third, divided by minus 6. So let's do this division by minus 6. I'll just jump over here. Equals, so 12 divided by minus 6 minus 2 plus, or now this is actually really swapped around, minus or plus because they're negative, and 2 divided by 6 is a third root 15. So there you go, there's your final answer. Now it is okay if you just want to leave it in that form, or if you prefer, you can change it a little bit to be 6 or negative 6 minus and plus root 15 divided by 3. That also is totally fine, or you can make it a decimal. So there you go, we've solved it using the quadratic formula. It was a whole lot easier than doing this method here, especially with such strange, weird numbers. Alright, I might as well at this point mention a thing called the discriminant. The discriminant is just this bit here under the square root sign. Okay, and it's important for a reason I'll mention soon. So it's b squared minus 4ac we call the discriminant. Now the reason it's important is because we've always got two solutions if this thing here is a number. So here it was square root of, well, where's my mouse gone? Here is square root of 15 plus or minus square root of 15. So we've got two solutions which we'll always have if this discriminant exists. So it exists if it's positive, because you can only have the square root of a positive number. You can't have the square root of a negative number. So if this discriminant is positive, in other words, if it is larger than 0, then we have two solutions. Two solutions. Now, if the discriminant is actually equal to 0, then that's allowed as well, because the square root of 0 is 0. But it will mean that we won't have this plus or minus bit. It will just be minus b over 2a, which means we have only one solution. Now, if this discriminant bit is actually less than 0, if it's smaller than 0, it'll be a negative number. And the square root of a negative number is not allowed, so that'll be 0 solutions. So what does 0 solutions mean, you might ask? Well, if here's a set of axes, one possibility where there's 0 solutions is this one here, where it's not actually touching or going through the x-axis. That's 0 solutions. Another one might be down here. It's a bit of a different, more dilated quadratic, but it's also not touching the x-axis, so it also has 0 solutions. And that is why the discriminant is an important factor that we need to investigate sometimes to see if we have any solutions. Okay, that's it for now. See you in class.